where we have things get more interesting. So again, here's part two. Part two of trig functions. And right now, all I'm telling you about this is that it's just sine and cosine. I'm going to do 3 of them, and then I'm going to ask you to do the other 3 because this you do need practice for. Now, I will tell you that the class does get a little bit more challenging with these kind of questions. Now, there are some strategies that I'm going to tell you here. So part 2 is, again, 2 trig, where 1 sine and 1's cosine. So if you look at question number 12, and notice that, for, again, keeping this simple, other than the question number 17 and number 14, all of our thetas actually end up just being x's or thetas. So if you have sine and cosine, boring old right there together, you could make u either trig function. Because in these 2 cases, usually your u is going to be at least, well, it's going to be a trig function. The whole thing, not just the theta. Now, if you have sine and cosine setting right beside itself, then your u is most likely, the best way to do u is to actually make it sine. Because if you do that, your du is going to be cosine, and you don't have to worry about a negative. If I make u cosine, your derivative of cosine is negative sine, and you have to worry about a negative. So what I'm going to do is I'm going to do this question, and I'm going to solve it with u equaling sine of x, because this becomes a really simple problem to do. And check this out. And by the way, I'm actually recording this. So, Joe, I'm recording this so you can listen to it later as well. So, u is equal to sine of x. Du is going to be equal to cosine x dx. Look how easy and wonderful this question becomes, because u is right here, and du is all of that. Everything is in this particular example. So, when we do this question, I'm going to look at integration of u du, right? This is the u, and this is the du. You're integrating now a variable, au, just like you would integration of x. How do I integrate u? How do I integrate u? How do I integrate x? How do I integrate a variable? U squared over 2. That's exactly what you do. U squared, that does not look like a 2. U squared over 2. So you can see a little bit of difference in what we did before, right? So u squared over 2 plus c, and then the last thing you're going to do here is you're going to replace your u, and I'm going to go ahead and pull out the 1/2, right? I can pull it out. So I'm going to replace my u with sine of x. Now I'm going to tell you how I write this answer, and again, I don't care what you do for it, but you'll see this commonly written as that. Okay? So they're both the same thing. What I do not want to see you write on your paper that is wrong, and we've actually, I think, had this conversation before, that's not sine of x quantity squared, right? That's the sine of x squared. Okay, so when you do question 14, the only issue you're going to have is you're going to make u sine of 3x, and so you have to then incorporate the chain rule, and I want you to try this without me kind of telling you about it. So your question is going to be a little bit different, but mostly your answer is going to be similar to what you see right here. All right, let's look at question number 13. Now, what I'm about to write on the paper, I don't want you to copy because what I'm going to do is wrong. Because again, I don't want you to think that u is always going to be sine of x. So for this one, if you make u equal to sine of x, or negative sine of x, it doesn't really matter. My derivative, again, this is wrong, is cosine of x dx. I do not have cosine in my integral. I know that looks weird for me to say that. I do not have cosine in my integral. I have 1 over cosine in my integral. That's not the same thing. So if you look at this, you have this actual piece right here. So what I want to make sure you understand is there's no cosine there. It's actually 1 over cosine. So what we're going to actually do here is we're going to make our u equal to cosine of x. Now I'm going to give you this is correct. So now we're working the right way here. So cosine of x is the right answer because the derivative of this is going to be negative sine x dx. Okay? So what's perfect about this, and I'm highlighting again, is my du is all right here, and my u is right here. The reason why, if you make u sine of x, your derivative is cosine of x. That's not cosine of x, it's 1 over x. So you have to make this right here match what you see in your integral. Now, I'm going to finish this problem up, and then we're going to talk a little bit more about it. So I already have a negative here. I don't have to pull that out. So everyone see that? Since there's already a negative in the answer, I do not have to pull that out. So I'm going to be left with du on the top, and then u squared on the bottom. The reason why I wrote it like this, because I want to make sure everyone feels comfortable, because sometimes you'll see that on your paper. It's exactly this right here. These are numbers. If, believe it or not, du is a number. You learned that with Riemann sum. U squared is a number. So most of you will probably write it, and I'm going to try my best to write it like this for you, but that is something you will see on your paper as well. And this becomes pretty easy to integrate. But before I get to that, everyone feels okay with what I'm doing? Okay, so I'm going to integrate this thing, and when I integrate, I'm going to integrate this as u to the negative 2 du, which ends up being u to the negative 1 over negative 1 plus c. The integration part of this, you realize I'm going to go incredibly fast. We've done this so many times now. So, and then I just replace this with u. So I go back here, and I say, okay, well, in this example, I get negative 1. Actually, let me write it this way. I have my negative 1 over my u is cosine of x plus c. And if you don't understand what I did there, then I really just did this. Right? I brought the negative to the top, and I dropped the u to negative 1 down, and then replaced it with my cosine of x. Okay, so what strategies do I want you to get out of this? Well, if it's not a sine and cosine, then what trig function's raised to a power? That's what you want your u to be, just like with the polynomials. So if you look at question number 17, and this is the one I want you to do by yourself, because it's challenging. Can you see, actually, let's look at 16 for a second. Look at 16 for a second. Which one of those has a power under it? Cosine. So your u here is going to be cosine of x. Which one over there has this power to it? Sine. Your u is going to be the sine of theta. What about good old 17 right here? So you see it, but now what's actually in the power? It's the sine of x squared. So what I want to do now is I want you to try these three questions. Actually, let's do this, because you just did 15. Let's try to make sure you feel comfortable with this. And I'm going to come around because, like I said, this is where I have to make sure for what we're going to be doing later in this course, understand this. So try 14, 16, and 17, because 15 is exactly like number 13. So if you could try for me, with the people around you, question number 14, 15, 16, and 17. I'll write the answers up for you as well. Please talk to each other. Discuss. This is a really good time to chat and make sure you understand these questions, because part 3, we go a little bit more detailed.